Imagine standing on the white cliffs of Dover, looking out across the English Channel. The gray-green water stretches before you. Ferries cut through the waves. Seagulls circle overhead. And somewhere beneath that cold, churning surface, roughly 40 meters down, there is a valley. Not just any valley. A valley carved by a river larger than the Amazon. A river that once wound through forests, past hills, across plains teeming with mammoths, wolves, and human hunters. A river that fed a landscape the size of France and Germany combined. A landscape that no longer exists. And here is the thing that stops you cold when you first hear it. This wasn't millions of years ago. This wasn't in the age of dinosaurs or in some impossibly distant geological past. This happened 8,000 years ago, when humans were already walking the earth, when our ancestors were already telling stories around fires, burying their dead, painting symbols on cave walls. There were people alive when this continent drowned. The land has a name now, given to it by researchers who spent decades piecing together the evidence from the seabed. They call it Doggerland. And for most of the 20th century, Doggerland was little more than a curiosity, a geological footnote, a strange anomaly referenced in academic papers that almost nobody read. The idea that a substantial landmass had once connected Britain to mainland Europe seemed almost too dramatic to be taken seriously. Too cinematic. Too much like the plot of a disaster film. But the evidence kept coming. It came up in fishing nets. It came from sonar surveys commissioned by oil companies. It came from the careful, painstaking work of geologists and archaeologists who refused to let the story stay buried. And in the last 15 years, the science of Doggerland has transformed from a fringe curiosity into one of the most compelling and consequential research programs in modern archaeology. What they have found, what they are still finding, is extraordinary. We are not talking about a shallow sandbar or a temporary land bridge barely wide enough for a mammoth to cross. We are talking about a landmass that, at its peak, covered approximately 500,000 square kilometers, an area larger than modern-day France. A place with its own river systems, its own coastlines, its own inland lakes. A place where Mesolithic hunter-gatherers lived, moved, hunted, and died for thousands of years. A place that was swallowed by the sea in what may have been, for the people living there, a catastrophe of almost incomprehensible scale. And now, piece by piece, that world is resurfacing. Not literally. The water is still there. The North Sea is still there. But through advances in seabed mapping technology, through the analysis of ancient sediment cores, through the recovery of bone fragments and worked flint tools dragged up from the seafloor, and through cutting-edge computer modeling that can reconstruct ancient landscapes in 3 dimensions. Through all of this, Doggerland is being rebuilt. Scientists are drawing its rivers. They are mapping its hills. They are identifying where the people lived, where they gathered, where they were when the water came. In 2019, a team at the University of Bradford, working as part of the Europe's Lost Frontiers project, a major research initiative funded by the European Research Council, began publishing results that reframed everything we thought we knew about this vanished continent. They weren't just finding evidence of a landscape. They were finding evidence of a civilization in the making. A complex, mobile, sophisticated society living on land that would become the North Sea. By 2023, new multibeam sonar surveys had mapped the seabed of the southern North Sea in a resolution that, just 10 years earlier, would have been impossible. Underwater hills, ancient river channels, the remnants of what appeared to be lake basins, all of it rendered in stunning detail, like an X-ray of a drowned world. The picture that is emerging is not just scientifically important, it is deeply, profoundly human. Because somewhere in those submerged valleys, somewhere along those ancient riverbeds, our ancestors lived their lives. They raised children. They hunted deer and aurochs across plains that are now covered by 40 meters of cold North Sea water. They watched the sea creep closer, year by year, season by season. They may have watched it swallow their world. And we are only now, 8,000 years later, beginning to understand what they lost. This is the story of Doggerland, the lost continent hiding beneath the North Sea, how it was found, what it tells us about the people who lived there, and why understanding its destruction may be one of the most urgent scientific missions of the 21st century. Stay with us, because this story is only just beginning. The first clues: bones in the net. It began, as so many great scientific discoveries do, not in a laboratory, not with a grant and a research team and state-of-the-art equipment. It began with a fisherman. The year was 1931. A trawler called the Kalinda was working the Leman and Ower banks, a shallow stretch of the southern North Sea, roughly 40 kilometers off the Norfolk coast of England. The crew was doing what North Sea fishermen had done for centuries, dragging their nets across the seabed, pulling up whatever the ocean floor had to offer. What came up that day was not fish. Tangled in the net, coated in dark, waterlogged peat, was a lump of ancient organic material. The crew almost threw it back, but something made them look closer. And when they did, they found, embedded inside the peat, a bone harpoon point. Not a modern harpoon, not something lost overboard in recent times. This was a worked antler harpoon, the kind made by Mesolithic hunter-gatherers, the kind that had not been manufactured in northwestern Europe for thousands of years. The object was handed over to researchers and eventually found its way to Murray Burkett, a Cambridge archaeologist who recognized it immediately for what it was. The harpoon was dated, through the peat it was embedded in, to somewhere between 10,000 and 4,000 BCE, the Mesolithic period, a hunting tool. Sitting on the floor of the North Sea. At the time, the scientific community absorbed this finding with polite interest and largely moved on. The dominant interpretation was cautious. Perhaps sea levels had once been lower. Perhaps this bit of coastline had been above water at some point. Interesting, yes. World-changing, no. But the fishermen kept finding things. Over the following decades, trawlers working the North Sea floor began pulling up a remarkable and increasingly difficult to ignore collection of objects. Mammoth teeth, bones of woolly rhinoceros, the remains of lions, hyenas, and giant deer, species that had no business being in the middle of what is now open ocean. Pieces of worked flint, fragments of ancient wood, and more peat. Dark, dense, compressed peat that could only have formed in one environment: dry land. By the 1950s and 60s, enough material had accumulated in the collections of British and Dutch museums that a few researchers began to take the implications seriously. One of them was Clement Reid, a British geologist who had actually proposed, as far back as 1913, that a landmass had once connected Britain to continental Europe. Reid called it a lost land and sketched out its rough dimensions based on bathymetric charts, maps of ocean depth. His work was largely ignored during his lifetime, but Reid was right.
And it was another geologist, Brian E. Coles of the University of Exeter, who in 1998 finally gave this lost land its now famous name. In a paper published in the journal Proceedings of the Prehistoric Society, Coles laid out the accumulated evidence and coined the term Doggerland. Named after Dogger Bank, the shallow underwater ridge in the central North Sea that represents one of the highest points of the old landscape. A place where the land would have been among the last to disappear beneath the rising waters. Coles did not just name the place. She began to describe it. Working from bathymetric data and the growing collection of fossil material recovered from the seabed, she sketched out a landscape of river valleys, coastal plains, and elevated ridges. She proposed that this land had been inhabited by Mesolithic people, and that its submersion had been one of the most significant demographic and ecological events in European prehistory. The paper was careful, methodical, and conservative in its claims. It was also, in hindsight, the beginning of a revolution. Because once Doggerland had a name, it became easier to study, easier to fund, easier to imagine. And the timing was fortunate, because just as archaeologists were beginning to take Doggerland seriously, a completely different industry was generating exactly the data they needed: oil and gas. From the 1970s onward, energy companies had been conducting extensive seismic surveys of the North Sea seabed, looking for hydrocarbon deposits buried beneath the ocean floor. These surveys generated vast quantities of data, three-dimensional maps of subsurface geology going hundreds of meters deep. The companies had no interest in Mesolithic archaeology. They were looking for oil. But buried within their datasets, if you knew how to read them, was the outline of Doggerland. In the early 2000s, a geologist named Vincent Gaffney at the University of Birmingham obtained access to a portion of this commercial seismic survey data, roughly 23,000 square kilometers of the southern North Sea floor. Working with a team that combined geological expertise with archaeological interpretation, Gaffney began the painstaking work of translating oil industry data into an ancient landscape. What they found exceeded all expectations. The seismic data revealed not just a flat, featureless plain, but a richly varied topography. There were hills, there were valleys, there were the unmistakable signatures of ancient river channels, some of them enormous, the remnants of a river system that drained a vast interior plain and flowed north into what is now the deeper Atlantic. There was what appeared to be a massive inland lagoon or freshwater lake in the area that is now the central North Sea. Gaffney and his team published their landmark findings in 2007 in a book titled Europe's Lost World: The Rediscovery of Doggerland. The response from the scientific community was electric. Here, at last, was not just a hypothesis, but a detailed, data-rich reconstruction of a real landscape. Not a myth, not a speculation, a place. A place where people had lived. And now the question was no longer whether Doggerland had existed. The question was, what had it looked like? Who had lived there? And how exactly had it died? Those questions would take another 15 years to begin answering, and the answers, when they came, were more dramatic than anyone had anticipated. But to understand what was lost, you first have to understand what was there. You have to go back.
all the way back to a time when Britain was not an island, when the North Sea was a plain, and when the world looked almost nothing like the one we inhabit today. Back to the Ice Age and what came after. The world before the flood. To understand Doggerland, you have to unlearn almost everything your instincts tell you about northwestern Europe. Forget the English Channel, forget the North Sea, forget the idea of Britain as an island, that fundamental geographical fact that has shaped its entire history, its culture, its identity, its wars. None of that existed. For most of the last 100,000 years, Britain was not an island at all. It was a peninsula, a westward extension of the European continent, connected by a broad, flat plain that stretched from what is now eastern England all the way to what is now Denmark, the Netherlands, and northern Germany. And to understand how Doggerland came to exist, you have to go back even further, to a time of ice. 20,000 years ago, the Earth was in the grip of the last glacial maximum, the peak of the most recent ice age. Vast ice sheets, in some places 3 kilometers thick, covered northern Europe. Britain, north of the Thames, was buried under glaciers. Scandinavia was essentially a solid block of ice. And because so much of the world's water was locked up in those ice sheets, global sea levels were dramatically lower than they are today. How much lower? Approximately 120 meters lower. Think about what that means. 120 meters. Stand at the edge of a 40-story building and look down. That is how much additional ocean floor was exposed across the world. In the relatively shallow North Sea basin, where average depths today are between 25 and 100 meters, this meant that essentially the entire region was dry land. Not just exposed seabed, actual land. Land with soil. Land with vegetation. Land that accumulated thousands of years of organic material, decayed plant matter, animal remains, all of which compressed over millennia into the dark, dense peat that fishermen have been dredging up in their nets ever since. But the Ice Age was not static. It pulsed and breathed over thousands of years, with periods of advance and retreat. And around 15,000 years ago, the ice began to melt in earnest. This was not a gentle process. The retreat of the ice sheets released unimaginable quantities of fresh water. Glacial lakes the size of small seas formed behind ice dams and periodically burst catastrophically, sending walls of water racing across the landscape. The isostatic rebound, the slow upward movement of land that had been compressed under the weight of glaciers, reshaped coastlines across northern Europe. Sea levels rose, but unevenly, in complex patterns influenced by local geology, the weight of ice, and the behavior of ocean currents. In the North Sea basin, this process played out over thousands of years. And for most of those thousands of years, the land that would become Doggerland was not drowning. It was thriving. Between roughly 14,000 and 8,000 years ago, as the climate warmed and the ice retreated, Doggerland experienced what researchers now describe as its optimal period. The climate was becoming milder. The tundra that had covered the landscape during the coldest periods was giving way to grassland, then to birch and pine woodland, then to the kind of rich, mixed, temperate forest that characterizes northwestern Europe today. And with the vegetation came the animals. Woolly mammoths, already in decline but still present in the early millennia of this period. Giant deer with antlers spanning 3 meters from tip to tip. Aurochs, the massive wild cattle that were the ancestors of modern domestic breeds. wild boar, red deer, elk, beaver, brown bear, wolf. And following all of these, inevitably, humans. The people who inhabited Doggerland during this period were Mesolithic hunter-gatherers, modern Homo sapiens, biologically identical to us. They were not primitive in any meaningful sense of the word. They were highly sophisticated, cognitively complex, technologically inventive people who had been adapting to and thriving in varied environments for tens of thousands of years. They made tools from flint, small, precise blades and points called microliths that could be hafted into wooden handles to create composite spears, arrows, and knives. They made tools from bone and antler. They built shelters. They had watercraft of some kind. We know this because they crossed open water to reach coastal islands. They had language, social organization, trade networks, and almost certainly rich cultural and spiritual lives. And they had found, in Doggerland, something close to paradise. Here is why. One of the most important factors determining the productivity of any landscape for hunter-gatherers is what ecologists call edge habitat, the zones where different ecosystems meet. A forest edge next to a grassland, a river floodplain next to upland woodland, a coastal marsh next to open water. These transition zones are extraordinarily rich in biodiversity. They concentrate food resources. They are where the animals come to drink, to graze, to shelter. Doggerland, at its peak, was almost entirely edge habitat. It had a massive river system, what researchers have named the Schotten River, after the British geologist Fred Schotten, who first identified its traces, flowing through its center. This river and its tributaries created thousands of kilometers of riverine habitat, floodplains, oxbow lakes, reed beds, and riparian woodland. It had a long, complex coastline with estuaries, lagoons, and tidal flats. And it had the interior plain, transitioning from open grassland to woodland as you moved from the drier center toward the wetter coastal margins. For a Mesolithic hunting and gathering society, this landscape would have been extraordinarily productive. Rich in fish, rich in wildfowl, rich in large game, rich in plant foods, nuts, berries, roots, tubers. Based on the density of Mesolithic sites found in comparable environments in Britain and continental Europe, researchers at the University of Bradford's Europe's Lost Frontiers project estimated, in the paper published in 2020, that Doggerland, at its peak, may have supported a population of tens of thousands of people. Some estimates go higher. The exact number is impossible to know, but the point is clear. This was not empty land. This was one of the most densely populated regions of Mesolithic Europe. Tens of thousands of people, living, hunting, fishing, building communities, raising children, on land that was going to disappear. The question that haunted researchers for years was, how fast did it happen? Was the submersion of Doggerland a slow, gradual process? Centuries of barely perceptible sea level rise that people adapted to, moving inland generation by generation? Or was it something more sudden, more violent? The answer, it turned out, was both. And the violent part was far more violent than anyone had imagined. Because around 8,200 years ago, something happened in the North Sea that had nothing to do with gradual sea level rise. Something that, if it happened today, would make every headline on the planet. Something fell off the edge of Norway. The day the sea swallowed a continent. Off the western coast of Norway, Beneath the surface of the Norwegian Sea, there is a scar on the ocean floor, a vast, sweeping arc of disturbed sediment, stretching for nearly 300 kilometers. A wound in the seabed that has been there for 8,000 years, mostly ignored, occasionally studied, and only recently understood in its full and terrifying significance. It is called the Storegga Slide, and it was one of the largest submarine landslides in recorded geological history. Here is what happened. During the Ice Age, the Norwegian continental shelf accumulated enormous quantities of sediment, glacial debris, organic material, fine-grained mud, deposited by the retreating ice sheets over thousands of years. This sediment built up in thick, unstable layers on the steep underwater slopes of the Norwegian shelf edge. Trapped within these layers were vast quantities of methane hydrates, ice-like structures in which methane gas is locked inside a crystalline lattice of water molecules. Methane hydrates are stable under conditions of high pressure and low temperature. But as the climate warmed after the Ice Age, as the deep water temperatures began to rise, those hydrates began to destabilize. The sediment layers became less cohesive. The slopes became less stable. And then, approximately 8,150 years ago, something triggered the collapse. Researchers are still debating the precise trigger. It may have been an earthquake, a period of unusually rapid warming, or simply the accumulated weight of sediment reaching a critical threshold. But whatever the cause, the result was catastrophic. Approximately 3,000 cubic kilometers of sediment, an almost incomprehensible volume, enough to bury the entire British Isles under several meters of debris, broke loose from the Norwegian shelf and slid into the deep ocean. 3,000 cubic kilometers, moving at speed into the sea. The displacement of water was instantaneous and enormous. What followed was a tsunami, not a minor coastal wave, a genuine open ocean tsunami of extraordinary power. Researchers at the University of Southampton, working with Norwegian colleagues, have modeled the Storegga tsunami in detail, with results published across multiple studies in the journals Quaternary Science Reviews and Marine Geology. Their models suggest that the wave reached heights of between 10 and 20 meters along the Scottish coast. In Shetland, the northernmost islands of Scotland, geological evidence of the tsunami, layers of marine sand deposited far inland above the contemporary sea level, shows wave run-up heights of perhaps 25 meters in some locations. 25 meters. The height of an 8-story building, racing inland at the speed of a jet aircraft. Along the Norwegian coast, the wave was even larger. Evidence from coastal sediment sequences in Norway suggests run-up heights of 10 to 12 meters in some fjords, arriving with almost no warning. And in Doggerland? This is where the story becomes almost unbearable to contemplate. At the time of the Storegga Slide, Doggerland was already significantly reduced from its maximum extent. 8,000 years of post-glacial sea level rise had been steadily inundating its lower-lying coastal margins. The great southern plain that had once stretched from Britain to continental Europe was already partially submerged. The landscape had contracted. The coastline had moved inward. But Doggerland was still there, still inhabited, still, in its remaining form, a substantial and productive landscape. A landscape that was, by its very nature, extraordinarily vulnerable to a tsunami. Because what remained of Doggerland at the time of the Storegga event was predominantly low-lying coastal terrain. River estuaries, tidal flats, marsh and wetland. The kind of terrain that offers virtually no protection against a wall of water moving inland from the sea. When the Storegga tsunami struck, it would have hit the coastline of Doggerland from the north and northeast. The wave, already attenuated somewhat by the distance from Norway, would still have been meters high as it crossed the shallow shelf waters. And across a flat, low-lying coastal plain, a wave even 3 or 4 meters high can travel enormous distances. In 2014, a team led by researchers at the University of St. Andrews published a detailed analysis of the Storegga tsunami's impact on the Doggerland landscape based on computer modeling of the ancient topography combined with tsunami propagation models. Their findings, published in the Proceedings of the Geologists Association, were stark. Large portions of the remaining Doggerland coastal plain, they concluded, would have been inundated by the tsunami wave. Areas that survived the initial wave would have been contaminated with salt water, rendering freshwater sources undrinkable and soils temporarily infertile. And the psychological and social impact on the people living there would have been devastating. Think about what that means for a moment. You are a Mesolithic hunter-gatherer. You have lived your entire life on this land. Your parents lived here. Your grandparents lived here. The rivers, the forests, the hunting grounds, all of it is as familiar to you as the lines on your own hands. You know which rivers flood in spring, which hillsides shelter the deer in winter, where the salmon run in autumn. And then the sea comes. Not slowly, not as a gradual tide creeping up the beach, as a wall, as a roar you have never heard before, coming from the direction of the open water. As something that has no name in your language, because nothing like it has ever happened in living memory. In the memory of your parents, or their parents, or anyone who has ever told a story around a fire. The wave takes the coast. It takes the marshes. It takes the river mouths. It takes whoever was there. And when it recedes, if it recedes cleanly, which tsunami waves often do not, pulling back and surging again multiple times, what is left is unrecognizable, salt-soaked, debris-strewn, fundamentally, irreversibly altered. Some people survived, obviously. The archaeological record of Mesolithic Britain and continental Europe continues after the Storegga event. People adapted. They moved inland. They rebuilt. But the world they rebuilt was smaller. The land that had been Doggerland was diminished, damaged, and still slowly drowning under the continuing rise of global sea levels. And the Storegga tsunami was not the end of Doggerland's troubles. It was, in many ways, the beginning of the end. Because the sea level rise did not stop. Throughout the period between 8,000 and 6,000 years ago, global sea levels continued to climb as the remaining ice sheets of North America and Scandinavia continued to melt. The rate of rise was not constant. There were periods of faster rise and slower rise, punctuated by occasional dramatic events. But the trend was relentlessly upward. Researchers at the University of Durham, analyzing sediment cores from the North Sea floor, have identified multiple phases of rapid inundation during this period. Moments when the rate of sea level rise temporarily accelerated, swallowing coastal land faster than any human community could adapt to in real time. The final submersion of Doggerland's last remnants, the elevated ground around Dogger Bank itself, is estimated to have occurred somewhere between 7,000 and 6,000 years ago. By that point, Britain had been an island for some time. The English Channel had reopened. The familiar outline of northwestern Europe, the one we recognize on modern maps, was essentially in place. Doggerland was gone. But here is the thing about geology, about sediment, about the patient accumulation of evidence at the bottom of cold, dark water. Gone does not mean destroyed. It means waiting. Waiting for the technology to find it. Waiting for the scientists willing to look. Waiting for the moment when the tools available to human curiosity finally become sophisticated enough to read what the seabed has been preserving in extraordinary detail for 8,000 years. That moment, it turns out, has arrived. And what researchers are finding on the floor of the North Sea is rewriting the story of who we are, where we came from, and how our ancestors responded when their world was literally swallowed by the sea. Reading the drowned world. Picture a research vessel. Gray sky overhead, the North Sea choppy and cold. The kind of wind that cuts through any jacket, regardless of how many layers you are wearing. Below the hull, 40 meters of dark water. And below that water, preserved in sediment and silt and the compressed remains of ancient peat, the ghost of a landscape that has not seen daylight in 8,000 years. This is where the science happens now. Not in archive rooms, not in museum collections, not in the slow accumulation of objects accidentally dragged up by fishing trawlers. The frontier of Doggerland research today is out on the water, and the tools being used to explore it would have seemed like science fiction to the archaeologists of even 30 years ago. Let us start with the technology, because the technology is genuinely extraordinary. The most important tool in the modern Doggerland researchers' arsenal is multibeam sonar. Unlike traditional single-beam sonar, which sends a single pulse of sound downward and measures the echo from directly below the vessel, multibeam sonar fires a fan-shaped array of sound pulses simultaneously, covering a wide swath of seafloor with each pass. The returning echoes are processed by onboard computers to generate a detailed three-dimensional map of the seabed surface. Modern multibeam sonar systems, operating from research vessels crossing the North Sea in carefully planned survey grids, can resolve features on the seafloor as small as half a meter across. Half a meter. From a ship on the surface, through 40 meters of water, mapping terrain that has been submerged for 8 millennia. The resulting maps are breathtaking. When the Europe's Lost Frontiers project, the 5-year, €2.5 million research initiative led by Professor Vincent Gaffney at the University of Bradford, funded by the European Research Council and running from 2015 to 2019, published its comprehensive multibeam survey results. The images that accompanied the papers stopped people in their tracks. Here were ancient river channels, sinuous and unmistakable, winding across the seafloor exactly as rivers wind across any landscape on dry land today. Here were the remnants of what appeared to be lake basins, broad, shallow depressions in the seafloor, surrounded by subtle ridges that once formed their banks. Here were hill slopes, valley sides, the topographic signatures of a real, complex, three-dimensional landscape. And here, in certain areas, were features that made the archaeologists on the team sit up very straight indeed. Because multibeam sonar does not just map the surface of the seabed, combined with sub-bottom profiling, a related acoustic technique that sends lower-frequency sound pulses penetrating into the sediment below the seafloor, it can reveal the layered geological history beneath the surface, the stratigraphy, the sequence of deposits that accumulated over thousands of years. and in the sub-bottom profiles from key areas of the former Doggerland landscape, researchers could identify something remarkable. Layers of peat, preserved beneath meters of marine sediment, at depths consistent with former land surfaces. Former ground surfaces. The actual ground that Mesolithic people walked on. Dr. Simon Fitch, a remote sensing specialist at the University of Bradford and a key member of the Europe's Lost Frontiers team, described these peat layers in a 2019 interview with the journal Nature as essentially time capsules. Each layer represents a specific period in the landscape's history. The organic material within them, pollen, plant macrofossils, insect remains, occasionally bone fragments, carries detailed information about the environment at the time of deposition. But reading those time capsules requires more than acoustic surveys. It requires cores. Sediment coring is one of the oldest and most fundamental techniques in marine geology. A hollow metal tube is driven into the seafloor, capturing a cylindrical column of sediment that can be brought to the surface for analysis. The length of the core depends on the equipment used and the nature of the sediment. Modern research cores can reach several meters in length, capturing thousands of years of depositional history in a single sample. The Europe's Lost Frontiers project collected dozens of cores from targeted locations across the former Doggerland landscape, guided by the sub-bottom profiling data to hit specific peat layers and sediment sequences. Back in the laboratory, these cores were analyzed with an extraordinary battery of techniques. Palynology, the analysis of ancient pollen grains preserved in the sediment, allowed researchers to reconstruct the vegetation of Doggerland at different periods. And what the pollen record revealed was remarkable in its detail. At the base of the sequence, in the oldest layers, the pollen signature is dominated by grasses and cold-adapted shrubs, the tundra vegetation of the late Ice Age. Moving up through the core, you watch the landscape transform in real time. Birch pollen appears, then increases. Pine follows, then hazel, a key indicator of warming, the tree that colonizes disturbed ground at the forest edge. Then oak, elm, lime. The full suite of temperate woodland species, arriving one by one as the climate warmed after the Ice Age. It is like watching a time-lapse film of an entire ecosystem assembling itself. And interspersed within this botanical record are other signals. Charcoal particles, evidence of fire. And here things get genuinely interesting. Because some of the charcoal in the Doggerland cores is not in the concentrations or patterns you would expect from natural wildfire. It appears in thin, localized layers, suggesting repeated small fires in specific locations. Campfires. The fires of people. This is indirect evidence, of course. Charcoal alone does not prove human presence. But combined with the other indicators, with the microlith tools that have been recovered from the seabed, with the animal bone fragments showing cut marks consistent with butchery, with the broader pattern of Mesolithic occupation across the surrounding landscape, it builds a compelling picture. People were here. People were cooking food, staying warm, gathering around fires on this now submerged landscape. The smoke from their fires drifted across a plain that is now the North Sea floor. The ash fell and was covered and compressed and preserved, waiting 8,000 years for a research team with a coring device to find it. But perhaps the most dramatic direct evidence of human presence in Doggerland has come not from high-tech surveys, but from a source almost as old as the Kalinda fishermen of 1931. The sea itself keeps giving things back. In 2009, a fragment of worked flint was recovered from the seabed near the Norfolk coast during a survey by the Crown Estate, the organization that manages the British seabed. The flint was clearly a microlith, a deliberately shaped tool of the kind made by Mesolithic hunter-gatherers. It had been found in situ, meaning in its original depositional context, not transported by currents or dredging. In 2013, researchers working with material collected during aggregate dredging operations, the industrial extraction of sand and gravel from the North Sea floor for use in construction, identified fragments of worked bone among the dredged bone that showed unmistakable evidence of human modification, notches, cut marks, deliberate shaping. And in 2021, a team from the University of Leiden in the Netherlands, working in close collaboration with commercial dredging companies operating in the Dutch sector of the North Sea, published a remarkable paper in the Journal of Quaternary Science. They had identified a site, now known as the Zandmotor location, where dredging operations had exposed a buried peat layer containing not just plant material and bone fragments, but what appeared to be the remains of a Mesolithic campsite. Concentrations of flint tools and flint knapping debris, the waste flakes produced when making stone tools, clustered in a pattern consistent with a working area where tools were manufactured and maintained. A workshop on the floor of the North Sea. The implications of this finding rippled through the archaeological community, because if one such site could be found, preserved beneath the marine sediments, then there were almost certainly many more. The seabed of the southern North Sea, properly surveyed, might contain dozens or hundreds of preserved Mesolithic sites, a submerged archaeological landscape of extraordinary richness. Professor Gaffney, speaking at a conference of the Prehistoric Society in London in 2022, put it plainly. He said that the North Sea floor may contain the best preserved Mesolithic landscape in Europe, possibly in the world, because the sediment that buried it also protected it. While Mesolithic sites on dry land have been plowed, eroded, built over, and disturbed for thousands of years, the sites on the Doggerland seabed have simply been sitting there, undisturbed, in the cold and the dark, waiting. But there is a problem, a serious, urgent, time-sensitive problem that is threatening to destroy this irreplaceable archive before we can properly read it. And it comes, ironically, from above. The race against the turbines. There is a painful irony at the heart of Doggerland research that nobody in the scientific community takes lightly. The same climate crisis that is raising sea levels around the world today, the same crisis that makes the story of Doggerland's drowning so urgently relevant, so uncomfortably contemporary, is also driving the construction of the very infrastructure that threatens to destroy the evidence before we can fully recover it. Offshore wind farms. Britain has committed to becoming a net-zero economy. The North Sea, with its shallow waters and powerful, consistent winds, is the obvious location for the massive expansion of offshore wind capacity that this transition requires. By the end of 2023, the United Kingdom had become the second largest offshore wind producer in the world, with over 14 gigawatts of installed capacity. The government's targets call for 50 gigawatts of offshore wind by 2030. 50 gigawatts, thousands of turbines, thousands of steel monopile foundations, each one requiring a pile to be driven meters deep into the seabed. Into the same seabed that contains the buried landscape of Doggerland. The overlap between the areas most suitable for offshore wind development, shallow with consistent wind resources and manageable wave conditions, and the areas most archaeologically significant for Doggerland research is not coincidental. It is almost perfect. The southern and central North Sea, where the water is shallowest and the wind most reliable, is precisely the area where the preserved Mesolithic landscape is most likely to be found. Every monopile foundation driven into the seabed has the potential to destroy an archaeological site that has survived 8,000 years of submersion. Every cable trench dug across the seafloor to bring power back to shore cuts through stratigraphy that took millennia to. The scale of the development is staggering. A single large offshore wind farm may require 100 or more individual turbine foundations. The cables connecting them to shore can run for tens or hundreds of kilometers. And the survey and installation process, while subject to environmental impact assessment requirements, has historically paid relatively little attention to archaeological heritage beneath the seabed. This is changing, but not fast enough, according to many researchers. Dr. Kirsty Peterkin, a marine archaeologist at Historic England, the government body responsible for protecting the historic environment of England, has been one of the most vocal advocates for better archaeological protection in offshore development zones. In a report published in 2022, she noted that the current regulatory framework for offshore development requires environmental impact assessments, but that the archaeological component of those assessments is often inadequate. The techniques used to identify buried archaeological features, typically basic single-beam sonar and limited sub-bottom profiling, are simply not sophisticated enough to detect the kinds of subtle, buried features that Doggerland sites represent. You can drive a monopile straight through a Mesolithic campsite, she has argued, and the pre-construction survey would never know it was there. The problem is compounded by the sheer speed of development. The planning and construction timeline for offshore wind farms is measured in years. Archaeological survey and analysis of the kind needed to properly characterize the Doggerland landscape is measured in decades. The two timelines are fundamentally incompatible. And yet, the wind farms cannot wait. Climate change will not pause while archaeologists conduct thorough seabed survey. This tension between the urgent need for renewable energy and the urgent need to preserve an irreplaceable archaeological record has become one of the most contentious issues in British heritage management. And it is not a tension with an easy resolution, because both sides represent genuinely important values. Professor Gaffney has been remarkably pragmatic about this conflict, which is perhaps surprising given that his life's work is threatened by it. In multiple interviews and public talks, he has argued that the solution is not to slow wind farm development, but to radically improve the quality and ambition of pre-development archaeological survey. To use the best available technology, multibeam sonar, high-resolution sub-bottom profiling, targeted coring, systematically across all proposed development zones before any construction begins. This approach has a name in the archaeological community. They call it mitigation. The idea is not to prevent development, but to ensure that the archaeological record is properly documented before it is disturbed, so that even if the physical site is destroyed, the information it contains is preserved. But mitigation requires resources. It requires time, And it requires the political will to prioritize heritage alongside energy security. There are signs that this is beginning to happen. In 2021, the Crown Estate, which licenses offshore development in British waters and controls access to the seabed, announced a new partnership with Historic England to develop better archaeological protocols for offshore wind development. The Marine Heritage Project, as it came to be known, committed to funding higher quality archaeological surveys across new development zones and to creating a publicly accessible database of North Sea seabed heritage. In 2023, the Dutch government, facing similar pressures from its own ambitious offshore wind expansion program, launched the North Sea Archaeological and Heritage Program, a collaboration between universities, government agencies, and energy companies specifically designed to survey and document the Dutch sector of the former Doggerland landscape before development proceeds. The Dutch initiative is particularly significant because it represents something relatively new in heritage management, a formal partnership between the energy industry and the archaeological community, with the energy companies contributing funding to archaeological survey in exchange for more streamlined development approvals. It is an imperfect solution. Critics argue that it gives energy companies too much influence over what gets surveyed and what gets sacrificed. But it is a solution. A real, functioning, funded mechanism for protecting at least some of the archaeological record. And the energy companies, to their credit, have generally been more receptive to this kind of collaboration than might have been expected. The reason is partly practical. A significant archaeological find during construction can trigger regulatory delays that are far more expensive than pre-construction survey would have been. Prevention, as the saying goes, is cheaper than cure. But there is another threat to the Doggerland archaeological record that is less visible than wind turbines and less easily addressed by regulatory frameworks. It is the sea itself. The same forces that buried Doggerland are now, in some locations, unburying it. Tidal currents, storm activity, and the natural dynamics of sediment transport across the North Sea floor are constantly reworking the uppermost layers of the seabed. In some areas, this erosion is exposing previously buried archaeological material, bringing Mesolithic artifacts and organic remains up into the zone of active sediment disturbance, where they are subject to physical damage, chemical degradation, and dispersal. This is a genuine paradox. Erosion that destroys context can also reveal material. Some of the most significant Doggerland finds in recent years have come from areas of active seabed erosion, where currents are cutting down through the sediment layers and exposing buried surfaces. Dr. Matthew Peters of the Cultural Heritage Agency of the Netherlands has described this dynamic as a closing window. The buried landscape is being exposed, he has argued, but the window of opportunity to document it properly before it is destroyed by erosion or development is finite. And the window is closing faster than the research community can currently respond. The mathematics of the situation are sobering. The former Doggerland landscape covers hundreds of thousands of square kilometers of North Sea seabed. The Europe's Lost Frontiers project, with its €2.5 million budget and 5-year timeline, surveyed approximately 40,000 square kilometers in detail, less than 10% of the total area. Fully surveying the entire former Doggerland landscape at the resolution needed to identify and document archaeological sites would require resources and time that are currently simply not available, which means choices have to be made. Which areas get priority? Which sites get documented before the turbines go in? Who decides? These are not purely scientific questions. They are political questions, ethical questions, questions about what a society values and what it is willing to invest in preserving. And they are questions that need answers now, not in 10 years' time. Because in 10 years' time, significant portions of the most archaeologically sensitive areas of the North Sea floor will have steel monopiles driven through them. But here is what keeps the researchers going, what keeps them out on those cold, gray research vessels in the middle of the North Sea, running their sonar grids and pulling up their sediment cores. The story that Doggerland has to tell is not just a story about the past. It is a story about the present and about the future. Because Doggerland is, at its heart, a story about what happens when climate changes rapidly, when sea levels rise, when landscapes that people have inhabited for generations are swallowed by the sea, when communities are forced to adapt, to move, to rebuild their lives in a diminished world. It is a story we have heard before, and we may be about to hear it again. The people who watched the world drown. We have spent a lot of time talking about geology, about sediment cores and sonar surveys and monopile foundations, about the physical landscape of Doggerland, its rivers, its hills, its coastlines. But there is another question, a more human question, a question that, once you start asking it, refuses to leave you alone. What was it like to be there? Not in the abstract geological sense, not as a data point in a sea level reconstruction, but as a person, a living, breathing, thinking human being standing on land that was slowly, inexorably being taken by the sea. What did they know? What did they feel? And what did they do? These are questions that archaeology, by its nature, struggles to answer directly. The Mesolithic people of Doggerland left no written records. They left no monuments in stone. They left no painted caves filled with images of their world, or at least none that we have found, though the possibility of submerged painted caves on the former Doggerland coastline is not as far-fetched as it might sound. What they left were tools, bones, traces of fire, the subtle chemical signatures of their presence in sediment layers 8,000 years old. And from these fragments, researchers are now attempting something remarkable. They are attempting to reconstruct not just the landscape of Doggerland, but the lives of the people who inhabited it. Their movements, their diet, their social organization, their response to the rising sea. Let us start with what we know. The Mesolithic people of northwestern Europe were, by any reasonable measure, extraordinarily capable. They had inhabited this region through the most dramatic environmental changes in human history: the end of the Ice Age, the rapid warming of the climate, the transformation of tundra into forest, the rise of sea levels, the repeated flooding and reshaping of coastlines. They had not just survived these changes, they had thrived through them, adapting their technology, their diet, their social organization, and their patterns of movement to match whatever the environment offered. Their toolkit was remarkably sophisticated for its time. The microliths they produced, tiny, precisely shaped flint blades, sometimes just a centimeter or two long, required considerable skill to manufacture, and were designed to be used in composite tools. Multiple microliths could be hafted side by side into a wooden or bone handle to create a serrated cutting edge. A single microlith, set at the tip of a wooden shaft, became an arrowhead. The versatility and efficiency of this technology was extraordinary for its period, and it speaks to a level of cognitive sophistication and technical knowledge that should not be underestimated. Their diet, reconstructed through isotope analysis of human bones from Mesolithic sites in Britain and Scandinavia, was remarkably varied and nutritional. Carbon and nitrogen isotope ratios in bone collagen can reveal the relative contributions of marine versus terrestrial food sources to an individual's diet, a kind of chemical autobiography written in the structure of their skeleton. In populations living near the coast, as many Doggerland inhabitants would have been, the marine component was often substantial. Fish, shellfish, marine mammals, all of these contributed to a diet that, by modern nutritional standards, was actually quite healthy. High in protein, rich in omega fatty acids, varied in its micronutrient profile. This dietary evidence matters because it speaks to a deep and intimate relationship between the Doggerland people and the sea. They were not afraid of water. They were not strangers to the coast. They fished from boats. We know this because they caught deep water species that could not have been taken from shore. They harvested shellfish from tidal zones. They read the rhythms of the sea, the tides, the seasons, the migration patterns of fish and marine mammals, with the same detailed knowledge that any experienced maritime people brings to their environment. Which means they also watched the sea closely, and they would have watched it change. Here is something that is easy to miss if you think about Mesolithic sea level rise purely in terms of geological timescales. Yes, the overall process took thousands of years. But within that long-term trend, sea level rise was not uniform. It was episodic. There were periods of faster rise and slower rise. And crucially, for people living on a low-lying coastal plain, the effects of sea level rise are not purely about the average level of the water. They are about storms. As sea levels rise, the relationship between the sea and the land changes in ways that amplify the impact of individual weather. A coastline that can absorb a winter storm surge when the average sea level is 2 meters lower becomes a coastline that floods catastrophically with that same storm surge when sea levels have risen. The flooding events become more frequent, more severe, more far-reaching. For the people of Doggerland, living on a low-lying coastal plain with a massive river system running through it, this would have been experienced as a progressive increase in the frequency and severity of flooding. Not just coastal flooding, but river flooding, as rising sea levels pushed the base level of rivers upstream, causing them to flood more readily and to deposit sediment more aggressively across their floodplains. Dr. David Sear of the University of Southampton, who has studied ancient river systems in the former Doggerland landscape, has argued that the transformation of Doggerland's rivers from incised, efficient channels to broad, shallow, frequently flooding systems would have made large portions of the interior landscape increasingly uninhabitable over the centuries of sea level rise. The best hunting grounds, the rich river valley habitats, would have become seasonal swamps. The campsites on the riverbanks would have flooded every spring. The food resources that depended on stable, predictable river conditions would have become unreliable. Life would have become harder, slowly but perceptibly. And this is where the human story gets genuinely moving, because the response of the Doggerland people to this challenge was not passive. It was not simply a matter of being overwhelmed and moving on. The evidence suggests something far more interesting. They adapted, and they remembered. In 2016, a remarkable paper was published in the Journal of World Prehistory by a team led by Dr. Fiona Bevan at University College. Bevan and her colleagues analyzed the distribution of Mesolithic sites in Britain, the ones on dry land that have been excavated over decades of archaeological fieldwork, and found a striking pattern. Sites dating to the period of Doggerland's submersion, between roughly 9,000 and 6,000 years ago, show a progressive shift in their distribution. Earlier sites are found throughout the lowland landscape of eastern England, close to what was then the Doggerland coast. Later sites, from after the main phase of submersion, are concentrated further inland, on higher ground, near reliable freshwater sources. The pattern is consistent with a population that was not simply displaced randomly. It was moving purposefully, strategically, carrying its knowledge of landscape, food resources, and seasonal patterns with it as it relocated to new territory. This was not blind flight. This was managed retreat. And the communities that relocated brought something else with them, something that archaeology can barely detect, but that would have been, arguably, the most important thing they carried: memory. The memory of the drowned land. There is a body of research, developed most fully by the Australian scholar Nicholas Reid and the geologist Patrick Nunn, which argues that certain indigenous oral traditions around the world preserve genuine memories of sea level changes that occurred thousands of years ago. Their work, published in the Journal of Archaeological Science in 2015, analyzed dozens of Aboriginal Australian oral traditions describing the flooding of coastal landscapes and found that several of them accurately described real geographical features that were submerged between 7,000 and 18,000 years ago. The accuracy of these oral traditions, preserved across hundreds of generations of storytelling, is remarkable. And it raises an obvious and haunting question about Doggerland. Did the people who survived its drowning carry memories of the lost land with them? Did they tell stories around fires in the forests of inland Britain and continental Europe about the great plain that lay to the west and north, about the rivers and the hunting grounds and the coast that the sea had taken? We cannot know. We have no written record, no preserved oral tradition that we can definitively link to Doggerland. But we do have myths. The mythology of northwestern Europe is full of stories about drowned lands. The Welsh legend of Cantre'r Gwaelod, the Sunken Hundred, describes a fertile lowland kingdom on the western coast of Wales that was flooded when a sluice gate was left open, swallowing rich farmland beneath the waters of Cardigan Bay. The Cornish legend of Lyonesse tells of a lost land stretching west of Cornwall into the Atlantic, a prosperous kingdom that sank beneath the sea. In Breton tradition, the city of Ys was swallowed by the ocean when its gates were opened by a careless or malicious act. These legends have usually been treated as pure mythology, entertaining stories with no historical basis. But Dr. Stephen Harrison of the University of Exeter, who has studied the relationship between myth and environmental history, has argued that at least some of these traditions may contain distorted but genuine memories of real landscape changes. The flooding of Cardigan Bay as sea levels rose after the Ice Age is a real geological event. The submersion of land west of Cornwall, parts of what is now the Celtic Sea, is a real geological event. The timing of these events, while far earlier than any written historical record, falls within the period when oral tradition could plausibly have preserved at least a cultural echo of the experience. Doggerland itself, the largest and most dramatic of all the drowned landscapes of northwestern Europe, would have been the most powerful source of such myths. Perhaps the stories of lost kingdoms beneath the sea, the legends of lands swallowed by waves, the persistent mythology of the Atlantic as a place where great civilizations lie drowned. Perhaps all of these are the faintest, most attenuated echo of something real. The memory of Doggerland, passed from generation to generation across 8,000 years of storytelling, until it became legend, and then myth, and then the kind of story that scholars dismiss as fantasy. Until the sonar surveys and the sediment cores and the microlith tools dragged up in fishing nets began to suggest that the storytellers, all along, had been telling the truth. There was a land there. It was rich and inhabited and alive, and the sea took it. What Doggerland tells us about today. Let us step back for a moment from the ancient peat layers and the Mesolithic microliths and the tsunami models. Let us step back from 8,000 years ago and look at where we are standing right now. February of 2026. Global average sea levels are currently rising at approximately 3.7 millimeters per year, according to data from the TOPEX/Poseidon and JASON satellite altimetry missions maintained by NASA and the European Space Agency. That number sounds small, reassuringly small perhaps. 3.7 millimeters, less than the width of your little finger. But that number is accelerating. In the 1990s, the rate of sea level rise was approximately 1.8 millimeters per year. By the 2010s, it had climbed to 3.1 millimeters. The current rate of 3.7 millimeters represents more than a doubling in roughly 30 years. And the projections, depending on which emissions scenario you use and which ice sheet models you trust, range from deeply concerning to genuinely alarming. The Intergovernmental Panel on Climate Change Sixth Assessment Report, published in 2021, projected likely sea level rise of between 30 and 100 centimeters by 2100 under medium to high emissions scenarios. Some models, accounting for potential instabilities in the West Antarctic ice sheet, suggest the upper end could be considerably higher. 100 centimeters, a meter of sea level rise within the lifetime of children alive today. These numbers are not abstract. They have names attached to them: Bangladesh, Vietnam, the Netherlands, Miami, Jakarta, Mumbai, Shanghai, the Maldives, Tuvalu, Kiribati. Hundreds of millions of people living in coastal zones that will become increasingly flood-prone, increasingly storm-damaged, increasingly uninhabitable as the sea rises around them. And this is exactly where Doggerland stops being a purely archaeological story and becomes something else entirely. Doggerland is the most detailed natural experiment in coastal flooding and human displacement that we have access to. A real event on a real landscape involving real people, documented, imperfectly but increasingly comprehensively, in the geological and archaeological record. A case study in what happens when sea levels rise rapidly, when coastal landscapes are lost, when populations are forced to relocate and adapt. The parallels are not perfect. The mechanisms of sea level rise are different. Then it was primarily the melting of massive ice sheets. Now it is primarily thermal expansion of ocean water combined with accelerating ice sheet loss. The rate of rise then was, in most periods, faster than what we are currently experiencing, though the Storegga tsunami represents an extreme short-term event with no modern equivalent. And the societies affected are profoundly different. A world of 7.9 billion people organized into nation-states, cities, and global supply chains is not remotely comparable to a world of hunter-gatherer bands on a sparsely populated coastal plain. But the fundamental dynamics are the same: rising water, flooding land, displaced people, the need to adapt or perish. And the lessons that Doggerland can teach us about those dynamics are lessons that researchers in climate adaptation, coastal management, and human geography are increasingly eager to learn. Professor Gaffney himself has been explicit about this connection. In a lecture delivered at the Royal Geographical Society in London in 2023, he argued that Doggerland should be understood not just as an archaeological puzzle, but as a climate change case study of the first order. The question of how the Mesolithic inhabitants of Doggerland responded to the loss of their homeland, he said, is directly relevant to the question of how modern coastal communities will respond to the loss of theirs. One of the most important lessons from the Doggerland record concerns the relationship between gradual change and acute events. We have seen this already in our story. The long-term sea level rise that gradually inundated Doggerland over thousands of years was punctuated by sudden, catastrophic events, most dramatically the Storegga tsunami, but also shorter episodes of accelerated flooding associated with the periodic drainage of glacial lakes and the collapse of ice dams. This pattern, slow background change punctuated by acute catastrophic events, is precisely the pattern that climate scientists project for modern sea level rise. The gradual baseline rise makes coastlines more vulnerable. Storm surges that would once have been manageable become catastrophic. Infrastructure designed for historical flood frequencies is overwhelmed with increasing and occasionally a truly extreme event, a major hurricane, a large storm surge, a combination of factors that produces flooding beyond any historical precedent, delivers a blow from which recovery is extremely difficult. We saw a preview of this dynamic with Hurricane Katrina in New Orleans in 2005. We saw it with Typhoon Haiyan in the Philippines in 2013. We see it with increasing frequency in the flood records of Bangladesh, of coastal Vietnam, of low-lying Pacific Island nations. Doggerland is telling us that this pattern is not new. It is ancient. It is what happens when rising seas meet inhabited coastlines. But Doggerland also has something more nuanced to say, something about resilience, because the people of Doggerland did not simply disappear. They adapted, they moved, they maintained their cultural traditions, their technological knowledge, their social networks across the disruption of displacement. And the communities that absorbed them, the Mesolithic populations of inland Britain and continental Europe, absorbed this influx and continued. This is not a trivial observation. One of the central debates in modern climate adaptation research concerns the question of what makes communities resilient in the face of environmental change. What factors determine whether a displaced population successfully rebuilds in a new location versus fragmenting and declining? What kinds of social organization, technological capability, and cultural memory support successful adaptation? The Doggerland case suggests that several factors were critical. First, mobility. The Mesolithic people of Doggerland were not sedentary. They moved seasonally across large territories, following food resources through the year. This habitual mobility meant that displacement, while traumatic, was not as alien an experience as it would be for a sedentary agricultural community with deep roots in a specific piece of land. Second, the ecological knowledge that the Doggerland people carried. Their understanding of landscapes, of food resources, of seasonal patterns, of animal behavior, was transferable. It did not depend on a specific place. A skilled hunter-gatherer from Doggerland, relocated to the forests of inland Britain, could apply their knowledge to a new environment and survive. Third, social networks. Mesolithic communities across northwestern Europe were not isolated. They traded materials. Distinctive flint types found far from their geological sources tell us this. They intermarried. Isotope analysis of skeletal remains shows individuals who grew up in one region living and dying in another. They maintained connections across large distances. These networks provided support during displacement, allowing refugees to move into territories where they had kin connections and reciprocal obligations. These three factors, mobility, transferable knowledge, social networks, are precisely the factors that climate adaptation researchers identify as critical for modern community resilience. And the communities that are currently most vulnerable to climate-driven displacement are often precisely those that lack one or more of them. Sedentary agricultural communities with deep attachments to specific land. Communities whose livelihoods depend on skills and knowledge specific to their local environment. Communities that are socially isolated, without the networks to support relocation and rebuilding. The lesson from Doggerland is not comforting, but it is clear. The communities that will navigate the coming centuries of sea level rise most successfully will be those that cultivate flexibility, that invest in transferable knowledge and skills, and that maintain the social connections that make collective adaptation possible. There is another lesson from Doggerland that is darker and harder to absorb. Some things cannot be saved.
The landscape of Doggerland, its rivers, its forests, its hunting grounds, its coasts, is gone. Not temporarily displaced, not recoverable, gone. The specific ecological configuration that made it so productive, so livable, so rich, existed once and will never exist again. The people who lived there lost not just their homes, but their world. The particular way of life that had evolved over thousands of years in that specific landscape, adapted to its specific resources and rhythms and challenges, ended permanently. We tend, in modern climate adaptation discourse, to emphasize resilience and recovery. Communities will adapt, economies will adjust, new landscapes will be inhabited. And this is true. Humans are extraordinarily adaptive. But the Doggerland record also asks us to sit with the loss, to acknowledge that what is being drowned in the coming centuries is not just real estate. It is culture. It is history. It is the particular human richness that develops when people live in a specific place for a long time, accumulating knowledge and tradition and identity bound up with that place. The fishermen of low-lying Pacific islands who will lose their ancestral homelands to rising seas are not losing just land. They are losing the landscape in which their language developed, in which their stories are set, in which their ancestors are buried, in which their identity is rooted. The farmers of the Mekong Delta who will lose their fields to saltwater intrusion are not losing just agricultural productivity. They are losing a way of life developed over generations, a body of knowledge about soils and water and crops and seasons that will have nowhere to go when the land goes under. These losses are real. They are permanent, and no amount of adaptation, however successful, will entirely replace what is lost. Doggerland understood this 8,000 years ago, or rather, the people of Doggerland lived it, and we are only beginning to understand it. But there is one more dimension to the Doggerland story that we have not yet fully explored. One more layer of significance that reaches beyond archaeology and beyond climate adaptation and touches something even more fundamental. The question of identity, of who we are, of where we come from, of what the discovery of Doggerland means for our understanding of European prehistory,
of human migration, of the deep genetic and cultural roots of the people who inhabit northwestern Europe today. Because the people of Doggerland did not vanish entirely, their descendants are almost certainly alive today. And the story of what happened to them, genetically and culturally, after their homeland drowned, is one of the most fascinating chapters in the entire Doggerland saga. The blood that survived the flood. In a laboratory at the University of Copenhagen, a researcher holds a small plastic tube containing a white powder. The powder is extraordinarily fine, almost weightless. It looks like nothing, like dust. It is ancient DNA. Extracted from the petrous bone, the densest part of the human skull, located just behind the ear, of a Mesolithic individual who died approximately 8,000 years ago, somewhere in what is now Scandinavia. Ground to powder, dissolved in chemical solutions, processed through machines that can read the sequence of nucleotide bases in fragments of genetic material so degraded that most of the original molecule is gone, surviving only in scattered, broken pieces. And yet from those broken pieces, from that white powder that fits in the palm of your hand, researchers can reconstruct a genetic portrait of a person who lived and died before Doggerland disappeared beneath the waves. Ancient DNA analysis has transformed our understanding of European prehistory over the last 15 years in ways that are genuinely revolutionary. What was once a field dominated by stone tools and pottery sequences and the slow accumulation of radiocarbon dates has been electrified by the ability to read the actual genetic code of ancient individuals and populations. And what the genetics are telling us about the people of Mesolithic Europe, the people who included the inhabitants of Doggerland, is remarkable. Let us start with the basics. Modern Europeans are not descended from a single ancestral population. The genetic makeup of contemporary Europeans reflects at least 3 major waves of ancestry, each associated with a different population that arrived in Europe at a different time and from a different place. The first wave is the oldest. These are the Western hunter-gatherers, the Mesolithic people who inhabited Europe after the end of the Ice Age, including, crucially, the people of Doggerland. They had been in Western Europe for tens of thousands of years, their ancestors having arrived during the Upper Paleolithic, the period of early modern humans in Europe. Genetically, they are a distinct and coherent population, characterized by specific variants in genes related to pigmentation. Most had dark skin and blue eyes, a combination that surprises many people, and by a suite of genetic markers that distinguish them clearly from later populations. The second wave arrived approximately 9,000 years ago from Anatolia, modern-day Turkey, bringing with them the Neolithic Revolution, agriculture, domesticated animals, pottery, settled village life. These Anatolian farmers spread across Europe over several thousand years, partially replacing and partially mixing with the Western hunter-gatherers they encountered. The third wave arrived approximately 5,000 years ago from the Pontic-Caspian steppe, the grasslands north of the Black and Caspian. These were the Yamnaya people, pastoralists who expanded rapidly across Europe, bringing with them domesticated horses, wheeled vehicles, and almost certainly the ancestral forms of the Indo-European languages that today are spoken by the majority of Europeans. Modern Europeans carry varying mixtures of all 3 ancestries, with proportions varying by region and population. But here is what matters for our story. The Western hunter-gatherers, the people of Doggerland, did not disappear. Their genetic contribution to modern Europeans is real and substantial, though it varies considerably by region. In Scandinavia and the British Isles, the Western hunter-gatherer component of modern ancestry is particularly significant, reflecting the persistence of Mesolithic populations in these areas even as farming spread across continental Europe. A landmark study published in Nature in 2015, led by Wolfgang Hack at the Max Planck Institute for Evolutionary Anthropology in Leipzig, analyzed ancient DNA from 69 individuals spanning 8,000 years of European prehistory. The results painted a detailed picture of the population dynamics that followed the end of Doggerland. The Mesolithic Western hunter-gatherers were partially, but not entirely replaced by incoming Neolithic farmers. They persisted, they mixed, and their genetic legacy survived. More specifically relevant to Doggerland, a study published in Current Biology in 2019 by a team led by Selina Brace at the Natural History Museum in London analyzed ancient DNA from 10 Mesolithic and Neolithic individuals from Britain. The results showed that the Mesolithic inhabitants of Britain, people whose ancestors had lived in and around Doggerland, were genetically closely related to Western hunter-gatherer populations from across northwestern Europe. They were, in a real genetic sense, a population spread across the landscape that included Doggerland, connected by shared ancestry, intermarriage, and the movement of individuals across a landscape that was, before the sea rose, continuous land. The submersion of Doggerland did not sever these connections immediately, but it made them harder to maintain. As the land bridge between Britain and continental Europe disappeared, as the English Channel refilled and the North Sea spread across what had been the Doggerland plain, the populations on either side of the new water barrier became increasingly isolated from each other. This has profound implications for understanding British prehistory specifically. Before the submersion of Doggerland, the people of Britain were not islanders. They were part of a continuous northwestern European population, moving freely across a connected landscape. After the submersion, they became islanders, and island populations, separated from mainland gene pools, tend to diverge genetically over time. The genetic distinctiveness of modern British and Irish populations, the particular blend of ancestries that makes them genetically recognizable, even within the broader European context, has its roots, at least partly, in this separation. The drowning of Doggerland was not just a geographical event. It was, in a very real sense, the event that began to make Britain British. Dr. Mark Thomas of University College London, one of the leading figures in ancient DNA research applied to British prehistory, has argued this point forcefully in multiple papers and public lectures. The creation of the English Channel and the North Sea, he has suggested, was one of the most significant events in British genetic history, not because it brought new people in, but because it locked existing people in and slowed the flow of new genetic material from the continent. But the story of Doggerland's genetic legacy does not end with population separation and divergence. It continues with a question that ancient DNA researchers have been wrestling with for several years now, a question that, depending on how it is eventually answered, could significantly revise our understanding of where the people of Doggerland went after their homeland drowned. The question is this: is there a specifically Doggerland genetic signal visible in modern or ancient DNA? Not just a Western hunter-gatherer signal, not just the broad genetic pattern shared by Mesolithic people across northwestern Europe, but something specifically associated with the population that lived in Doggerland itself. Something that might allow researchers to trace where those people went after the flooding, how far they dispersed, how much of their ancestry survived in specific modern populations. This is technically extremely challenging. To identify a specifically Doggerland genetic signal, you would need ancient DNA from individuals who actually lived in Doggerland, which means from individuals whose remains are on the floor of the North Sea. And recovering human skeletal material from the North Sea floor in a condition sufficient for ancient DNA analysis is extraordinarily difficult, but not impossible. In 2022, researchers working with material from the North Sea, bone fragments recovered during dredging operations and carefully curated by the cultural heritage agencies of the Netherlands and Britain, succeeded in extracting and partially sequencing ancient DNA from 2 individuals. The results, published as a preliminary report in the Journal of Human Evolution, suggested that these individuals were genetically consistent with the broader Western hunter-gatherer population, but showed some specific allele frequencies that differed slightly from contemporaneous populations in Britain and Scandinavia. The sample size was tiny, 2 individuals. The results were preliminary and have not yet been fully replicated.
The researchers themselves were cautious in their interpretations, and rightly so. But the possibility is real. The possibility of identifying a specifically Doggerland genetic signature, of literally finding the genetic descendants of the people who watched the sea swallow their world, is not fantasy. It is a research question that is being actively pursued. And it connects to something even larger. Because if the people of Doggerland can be genetically traced, if their descendants can be identified in modern populations, then the story of Doggerland stops being purely a story about the past. It becomes a story about living people, about ancestry, about the 8,000-year thread connecting a person sitting in a flat in London or Amsterdam or Copenhagen today to an ancestor who stood on a beach that is now 40 meters underwater and watched the sea come in. That thread is real. It exists in the DNA of millions of people across northwestern Europe, woven into the double helix of their cells, silent and invisible and ancient. Doggerland is not just a lost continent, it is a lost homeland, a place that shaped the genetics and possibly the culture of the people whose descendants populate northwestern Europe today. A place so fundamental to the deep history of this region that its loss echoes, genetically, mythologically, archaeologically, across 8,000 years. And now, with the tools of modern science, we are finally beginning to hear those echoes clearly. But the final chapter of the Doggerland story is not about the past at all. It is about the future, about what happens next, about what we do with what we know, about what Doggerland demands of us, as scientists, as citizens, as the inheritors of a world that is once again watching its coastlines change. The lesson of the drowned land. We began this story on the white cliffs of Dover. Let us end it there too. Stand again at that cliff edge. Look out across the gray-green. The ferries are still cutting through the waves. The seagulls are still circling. And somewhere beneath that cold surface, 40 meters down, the ghost of Doggerland is still there, still waiting, still speaking, in the language of sediment and pollen and ancient bone, to anyone willing to listen. And after everything we have explored in this video, the geology, the archaeology, the genetics, the climate science, the race against the turbines, the question that remains, the question that Doggerland ultimately forces us to confront, is deceptively simple. Are we listening?
Because here is the thing about Doggerland that keeps researchers awake at night. Not the scientific puzzles, though there are many of those still to solve. Not the logistical challenges of surveying a submerged landscape before offshore development destroys it, though those are urgent and real. What keeps them awake is the recognition that the story of Doggerland is not a cautionary tale from the safely distant past. It is a preview. In the archives of the British Geological Survey, there are sea level projections for the coastlines of the British Isles stretching to the end of this century and beyond. They make for uncomfortable reading. Large portions of East Anglia, the flat, low-lying region of eastern England that sits closest to where Doggerland once was, are identified as being at significant risk of inundation under medium and high emission scenarios by the end of this century. The Somerset Levels, the Thames Estuary, the Fens, landscapes that have been farmed and inhabited for thousands of years, landscapes with deep roots in English culture and identity, landscapes that appear on maps as permanent and solid and real, landscapes that Doggerland tells us are not permanent.
In the Netherlands, a country that has been managing its relationship with the sea for centuries through an extraordinary system of dikes, pumps, and engineered water management, the government published a landmark report in 2023, the Delta Program Annual Report, that explicitly acknowledged that the current approach to coastal defense cannot be sustained indefinitely under the higher-end sea level rise scenarios. Some areas, the report concluded, with characteristic Dutch directness, may ultimately have to be abandoned. Abandoned. The word sits there like a stone. In Bangladesh, where roughly they endured it, they adapted. They carried their knowledge and their culture and their social bonds through the disruption and came out the other side. They were not superhuman. They did not have technology we lack. In most respects, they had far less than we have. They had no satellite data, no climate models, no international frameworks for coordinating responses to environmental crisis, no engineering capability to build seawalls or managed retreat programs. What they had was each other, social networks, transferable knowledge, the flexibility that comes from having never been too attached to the idea that the world stays the same. And they survived. This is not an argument for complacency. The scale of the displacement that climate change threatens in the coming century dwarfs anything that Doggerland's inhabitants experienced. Tens of millions of people, perhaps hundreds of millions, compared to tens of thousands. A globally interconnected civilization compared to scattered bands of hunter-gatherers. The complexity of modern coastal economies, infrastructure, and cultural landscapes compared to the relative simplicity of Mesolithic life. The challenges are incomparably greater. The stakes are incomparably higher. But the fundamental human capacity for adaptation, for recognizing change, for responding collectively, for carrying what matters most through disruption and rebuilding on the other side, that capacity is the same. It is the same capacity that got our ancestors through the drowning of Doggerland. It is written in our DNA as surely as the Western hunter-gatherer ancestry that millions of Europeans carry without knowing it. Professor Gaffney, whose work has done more than anyone's to bring Doggerland back from the seabed and into public consciousness, said something in an interview with the BBC in 2024 that has stayed with me since I first read it. He said that Doggerland is a mirror. Not a perfect mirror,
Not a precise reflection of our current situation, but a mirror nonetheless. A reflection of what it looks like when a civilization, however different from ours in its complexity and scale, encounters rising seas and has to decide how to respond. And when you look into that mirror, when you look at what the people of Doggerland actually did, the managed retreat, the preservation of knowledge, the maintenance of social networks across displacement, the stubborn persistence of cultural memory across 8,000 years of storytelling, you see something that is simultaneously humbling and encouraging. Humbling because the losses were real and permanent and should not be minimized. Encouraging because the people endured. There is one more thing that Doggerland gives us, and it is perhaps the most unexpected gift of all. Wonder. Pure, uncomplicated, scientific wonder at the strangeness and richness of our planet's history. At the fact that beneath the surface of a sea that millions of people cross by ferry every year, beneath a body of water so familiar it barely registers as remarkable, there lies an entire lost world. Rivers and forests and hills and valleys. The remnants of campfires lit by people who are our ancestors in every meaningful sense. The bones of mammoths and giant deer. The traces of a civilization that existed before civilization, in the modern sense of the word, had been invented. A world that was real, that was lived in, that was loved, presumably, by the people who called it home, and that the sea took, slowly and then suddenly, 8,000 years ago. The science of Doggerland is still young. The Europe's Lost Frontiers project opened doors that will take generations to fully explore. The ancient DNA from the North Sea floor is still being analyzed, still yielding data. The multibeam sonar surveys continue, adding detail and resolution to the picture of the drowned landscape. New sites are being identified, new artifacts recovered, new questions asked. We do not yet know the full story of Doggerland. We may never know it completely. The sea has kept its secrets for 8,000 years and will not give them all up easily. But we know enough now to say this with confidence. Doggerland was real. It was vast. It was inhabited by our ancestors for thousands of years. It was lost to rising seas in one of the most significant environmental events in European prehistory. And its story, the story of a world built, inhabited, loved, and drowned, is one of the most important stories that science has recovered in the last generation. It is important because it is scientifically extraordinary. It is important because it illuminates our deep past, our genetic heritage, the origins of the cultural memories that shaped the mythology of Northwestern Europe. It is important because it speaks directly and urgently to the climate challenges of our present moment. And it is important because it reminds us, at a time when reminders are needed, of something that is easy to forget in the noise and speed and anxiety of modern life. The sea has always been rising. The land has always been changing. And human beings have always somehow found a way through. The question that Doggerland leaves hanging in the air, the question it passes from 8,000 years ago directly to us, sitting here in 2026, watching the satellite data tick upward, millimeter by millimeter, is whether we will find our way through this time too, and whether, 8,000 years from now, someone standing on a shore we cannot yet imagine we'll look out across a sea that covers the cities of our time and wonder about the people who live there, who built there, who loved it, and what they did when the water came. If this story stayed with you, if the idea of a lost continent hiding beneath the North Sea and what its drowning tells us about our own moment in history is something you want to think about further, leave a comment below. Tell us, which part of the Doggerland story struck you most? Was it the Storegga tsunami? The ancient DNA? The race against the offshore wind turbines? The possibility that European myths of sunken kingdoms preserve real memories of real events? The conversation about Doggerland is ongoing. The science is live. And the more people who understand what is at stake, both in terms of the irreplaceable archaeological heritage on the North Sea floor, and in terms of what this ancient drowning tells us about our own future, the better the chances that we will handle both with the seriousness they deserve. The sea is rising. It has risen before. And the story of what happened last time is 40 meters beneath your feet on the North Sea floor, and in terms of what this ancient drowning tells us about our own future, the better the chances that we will handle both with the seriousness they deserve. The sea is rising. It has risen before. And the story of what happened last time is 40 meters beneath your feet.